Hi, this tutorial shows DiffFit's demo usage scenario 2, composite multiple structures in the disk tab. We will follow this documentation. Scenario 2, composite multiple structures. The logic of composite is very similar to the one fitting the one of the fit a single structure in the interactive mode, only that you need to specify the file path from the disk. So if you are really compositing individual smaller subunits, then you might also need to prepare them by splitting them from a large complex. So we will use the example PDB 8SMK and its associated EMD map 40589. So we can open them by either downloading the files or use this command. So I will use this command, open 8SMK, and go to the Utilities tab. So we are gonna split this complex with 6 chains into individual chains. So the output folder is the folder containing those individual chains, PDB or MMCIF files. You can select the folder to any other folder, and then after that select this structure and click split. Now it's in your work folder's split out subfolder. The working folder of Camera X is usually the desktop if you haven't changed it. So here we have the split out, and because the chain, there are only 3 unique chains, so that's A, B, C, and we're gonna delete the D, E, F chains. Then after that we need to simulate a map for each structure in the folder. So we can, here by default the structures folder is already split out, and then by default the output folder for the simulated map is SimOut. You can change that to other folders in your case. The structures need not to be splitted here in the simulated map. You can prepare your individual structures in a folder and then simulate at here. The resolution you can choose to match your target volume. Later on we are going to open, but 5.0 angstrom works very well in most cases. So let's click simulate to simulate them, and now you should be able to see another folder called SimOut. That's these simulated maps. Now we can come to this disk mode, disk tab, to specify the target volume. We haven't downloaded that yet. We need to download that from here. Now let's unzip it. It's 40589. Okay, that's here. So let's put it here. Okay, we need one parameter. That's the target surface threshold. There would be a suggested one. We can open that and see. Open 40589 from EMDB. It will download and then open and show at the suggested threshold value. The suggested level value is 5. It's That's okay. Probably we can. All of these values are fine for DiffFit. So we can try with 5 first. So let's copy the path and file. The structures folder is gonna be this folder because it's on my working folder, so I can just say split out. In the sim folder, likewise, I can just put sim out. Sorry, the structure folder is in split out. The output folder, I can put DiffFit out, Composite. The target surface, as we chose just now, the default is 5. Actually, like if you are fine with this one, say 3, we can go by 3. Feel free to try a few others. The DiffFit is robust, very robust against this threshold. Just don't do like 12 or where you don't see anything, or even 10, or also don't do like 0.03 where there are too many noises. Somewhere between 1 and 5 is fine. You don't have to put this threshold level because this is running from the disk. Nothing here in the interactive environment will be using as input. So after that, we can hit run, and we can change some settings here. The number of shifts and number of quaternions you multiply together will get here, for example, 1000 initial seeding placement. You can increase that, but this 1000 is fine for this relatively small map. Now let's hit run. We are following the text guide. Already finished this, and we are here. After that, we use a similar way as in the first scenario to view the results. That's at here. Yeah, we start clicking the rows and go through the fitting results. So this you can maximize the window. You can change the transparent level so that we see where the structure is. And as a heads up, as a advice, we suggest you always fit the DiffFit result again by fitting map, the camera axis built-in fitting map, and see if it's makes better sense and compare between them. So usually camera axis fitting map will give a better result. We will automatize this process later on in our later version. So we can see that here it finds the model ID 0. That's the first structure in the folder. Here, in the desktop, and it also shows the file's name here. Later on, we will show the file name here in the table as well. And you can see there are 2 occurrences of the first structure, and we also find a placement of a smaller subunit here. And then these are, of course, you can see this doesn't make sense because it doesn't follow the map. So it looks like we got 3 reasonable fit. So I'm gonna choose them and fit by camera X command, here, and then I will save the structure. Save the structure in a new folder, Composite result, RESTful result, and this is the one of the A chains. I forgot which one is at the upper. I think the upper one is A2. I think. Okay, and then this one. Let's fit it, and then save the structure as A1. And we have one occurrences of B chains. That's let's fit it and save the structure B1. If I recall correctly, all the copies that's at the lower side is the first occurrence. Later on we will see why this will make our life easier, but this is not something critical. This is B1. I forgot one thing, that's we should zero the densities. So let's deal with this B1 first. So this is already refined by camera X, so I can simulate a volume, I can zero the density. Now with the first two, I need to refine it and simulate a volume, zero the density. The second one, refine it and simulate a volume, zero the density. Now what I'm gonna do is I'm gonna save this working volume. That's this one. So this is the original map. This is the map where we removed the already placed structures. So let's save this volume. You can save it by clicking this button here, or go from the save and save, choose the volume, and then choose that volume. Here it automatically saved this working volume, already chose for you. So I will save it on my desktop as round 1 input volume. Now we are gonna perform another round of fitting. So let's go to the desktop. I need to copy the path, so let's copy the path here, and I typed round 1 input.mrc. So the target volumes file format can be .map or .mrc. So the structures folder. Now what we can do, we can remove already the chain A, because we know the chain 2 occurrences of chain A has already been fitted. It's fine. Let's try just without removing it. Let's see what's the result. Sometimes in this case, it's the subunits is not the number of subunits is not huge, so it will be fine. It will still be able to find the result, but this will create some noises, of course. So now let's again change the threshold a bit. Probably go with the simple lighting or full lighting. Okay. Now we see one. Now this is, we are roughly we are skimming through the results. This is the second two. Now it's interesting that because we don't really know which one is the where should this structure be placed, either at here or there. We need to scrutinize the examine the structures very carefully. So we might change the threshold and see. I think this makes sense. This is a correct fitting. And then for a placement like this, it's not good because there are significant amount of atoms are outside. So let's go one by one. We probably also, before we examine, we probably also refine the fit. So does this one look correct? It might not be the correct one because I don't see the beta sheets and I don't see these alpha helices. So, and there are some other parameters that allows you to see. This inside is 0.28, correlation is 0.57. So it looks like this one and this one are some better candidate. So let's see. And if 1 is here and 2 is here, then that makes sense. And now let's scrutiny examine that. So that's it. Yeah, I think this one makes sense because the beta sheets follows the density. The other side, I'm not that expert in cryo-EM. It's not very clear to me, but we can see this number 2 here first. Yeah, I think this one follows the density. Yeah, this one follows density very well. Yeah, okay, we will take these two. So first one, refine it. Say simulate the volume. Let's first save the structure. This now I cannot. Okay, this is at the up, so I think it's the second. This is B1 is there. Okay, this must be B2, and here we have C2. Now there's supposed to be one more at the bottom. Let's see which one is that. I remember I saw it. Oh, yeah. Oh, holy! I made a mistake that I was looking at the bottom somewhere, so that's why it took me so long time to differentiate which one is the correct one. So I was a bit puzzled just now too. So DiffFit is the performance of DiffFit should be able to get the most correct ones at the top. Usually it is the top. So here it follows the density very nicely. Let's refine that, and let's save that as this is B, that's B2, right? Let's check the time. Yeah, B2 is the one we are fitting right now. Now here C, let's refine it and save it. This is at the top. The top ones I remember it's the second unit, so I will save that. Now there is another one that's here, that's 2. Of course, this, you can see this doesn't follow the density, so we reject that. Now here it follows the density nicely. Here you can tell. Let's refine it and save it. Save the structure. C1. So now you can see if we remove these 3 areas from the working volume, the round 1 input volume, then nothing is left. You can of course do so and zero the density, but you can already feel that there is nothing left that we need to do to further fit it. So now at this stage, then one will need to make a decision whether or not to further save the working volume and fit it again. You might even need to change the threshold value to see if you can fit more objects. Now, I think it's easy to come to the conclusion that there is nothing left. So let's close them all, and let's open the ground truth and our fitted result. We can even turn off the DiffFit tab. So open it as OK. That's what I mean by the A1 and A2. So this is A at the lower left. This is B also at the lower side. Yeah, the lower side is the first occurrence. So let's drop the result in. And we need to compare, to get the root mean square deviation, we need to combine them into a one model. So combine, I forgot the command. I have the command here in the wiki. It's combine this into a single thing. So A1 goes first and then B1. A1 is 2, then 4, then 6. So it's 2, 4, 6, and then B1, A2, B2, C2. So that's 3, 5, 7. Give it a new model ID. It's gonna be 8 because the last model ID we used is 7. A new lane, we can do fit or composite. 8 as a key. Okay. Okay, now we can remove them. We can close them. We can see these two, they are showing in different styles. So let's go for both of them this cartoon style and hide others. So now what we can do to compare them is I'm a little bit skeptical about the order of them. It looks like I didn't get the order correct, because if it's correct, it should be the color might be the same, or I might be wrong. Root mean square distance from model 1 to model 2. Number of atoms differ even. Let's do it again. Let's close this, open it. Let's see this. A, B, C, okay. I think that's A1. It's supposed to be this A. Yes. The B is here. I think that's B1. Yes. So C1 should be the lower side too. Yeah, that's C1. And then let's see if this is, yeah, C1 that goes first. So I think we are doing good. ABC, okay, then let's drop a 2B, 2C2 in. So now what we need to do is we need to combine 2, 3, 4, 5, 6, 7. That's gonna be ABC, ABC into model 8 with the name here. Okay, now if we just calculate the root mean, RMSD from number 1 to number 2, yes. Oh no, not number 2, number 8. Yeah, now we see the result is 0.132 angstrom, which is very good. So that's it for compositing a structure. Sorry for a few mistakes that I've made, and some of it I made it on purpose because this is a demo tutorial that these are the easy mistakes we are going to make. So you can try to composite others or real examples. The combine command and other split commands, you might consult the camera axis documentation for more information. Thank you.